Nurul Paramita from the Department of Medical Physiology, Faculty of Medicine, Universitas Indonesia. Welcome to the distance learning video presentation provided by the Department of Medical Physiology, Faculty of Medicine, Universitas Indonesia. This is the first of two parts video that will discuss about immediate cardiovascular responses to aerobic exercise. These are the main points that will be discussed in this video series. However, in part 1, we emphasize on physical activity versus exercise, aerobic versus anaerobic exercise, and oxygen uptake. Let us first begin with understanding the difference between physical activity and exercise. According to the American College of Sports Medicine, physical activity can be defined as any bodily movement produced by contraction of skeletal muscles that requires energy expenditure above the basal level. This includes daily activities such as doing household chores, gardening, walking up the stairs, etc. On the other hand, exercise defines as a subset of physical activities that is planned, structured, and repetitive. The aim of doing exercise is either to improve or to maintain one or more component of physical fitness. Based on energy requirement while doing muscle work, we can divide exercise into two types, aerobic and anaerobic exercise. The American College of Sports Medicine defines aerobic activity or exercise as any activity that uses large muscle groups, can be maintained continuously, and is rhythmic in nature. As the name implies, muscle groups activated by this type of exercise rely on aerobic metabolism to extract energy in the form of adenosine triphosphate or ATP from amino acids, carbohydrates, and fatty acids. This means that oxygen is always present and sufficient to promote and maintain aerobic metabolism in order to sustain certain level exertion over a long period of time. On the other hand, anaerobic exercise has been defined by the ACSM as intense physical activity of very short duration, fueled by the energy sources within the contracting muscles, and independent of the use of inhaled oxygen as an energy source. Without the use of oxygen, the cells refer to the formation of ATP via glycolysis and fermentation. This process produces significantly less ATP than aerobic exercise and leads to the buildup of lactic acid. Included in this type of exercise are the fast-twitch muscles contraction and sprinting, high-intensity interval training, powerlifting, etc. Exercise places an increased demand on the cardiovascular system in order to fulfill oxygen requirement of the working muscles, to carry nutrients, heat, and also metabolic waste products. To perform as efficiently as possible, the cardiovascular system performs responses which are usually short-term changes and would come back to the resting level as soon as the exercise ends. The immediate changes that are observed in the cardiovascular system is a coordinated response to meet the increased energy demand of physical work. These rapid alterations to exercise intensity and duration are known as the body's acute responses. Following a certain period of training, or as we call trained condition, the cardiovascular system and its components go through various adaptive, anatomical, and physiological changes that is almost permanent, causing a slight difference in cardiovascular parameters from the basic resting level in sedentary people. These changes are known as adaptive changes. In this topic, we will only discuss the body's response to an acute bout of exercise with emphasis on aerobic exercise. Even before a person begins to exercise, the heart rate increases above the resting level. This is known as anticipatory response. It is now established that the first increase in heart rate stems from the central nervous system known as central command. The central command modulates stress-related sympathetic outflow, including the sympathetic outflow related to exercise. Release of epinephrine and norepinephrine initiates several cardiovascular changes including increased heart rate prior to exercise, increased alertness, and the anticipation of exercise elicits all the components of the early response to exercise. In addition to the central command, the integrated cardiovascular response to exercise includes exercise pressure reflex and baroreceptor reflex. Exercise pressure reflex originating within the exercising muscles itself. Contraction stimulates stretch receptors and may activate chemoreceptors that sense metabolites. Stimulation of these receptors sends signals to the medullary cardiovascular center. This sensory input reinforces the central input to the cardiovascular control center and thus sustains the sympathetic outflow. During exercise, central command resets the sensitivity of the arterial baroreflex so that the heart slows only at a much higher arterial pressure. Aerobic exercise depends on how much oxygen can be delivered by the cardiovascular system and extracted by the working muscles. This is known as oxygen consumption or oxygen uptake. Under normal condition, at sea level, each 100 ml of arterial blood carries 20 ml of oxygen, so that 1 liter of blood carries about 200 ml of oxygen. Since the resting cardiac output is about 5 liters per minute, potentially 1,000 ml of oxygen becomes available during 1 minute. The amount of oxygen consumed by the body at rest is only 250 ml per minute. Thus, 750 ml of oxygen returns unused to the heart. This extra oxygen in the blood above the resting needs maintains what is called oxygen reserve, which is a margin of safety for immediate use if the need arises. During heavy exercise, the oxygen carrying capacity of the blood increases from 1,000 ml per minute up to 4,000 ml per minute. The oxygen consumption also increases during heavy exercise, indicated by an increase in the oxygen difference between arterial and venous blood. Here we show the changes in oxygen uptake which occur when a person performs maximal intensity exercise from a resting condition. Notice that even during heavy intensity of exercise, the blood oxygen content will not decline to zero. The determinants of oxygen consumption are summarized in the fixed equation as follows. Oxygen consumption equals cardiac output times oxygen difference between arterial and venous blood. Thus, there are two major factors that could limit maximum oxygen consumption. First, cardiac output, and second, capacity of active muscles to extract oxygen. These are the references that we used in preparing this presentation. This is the end of part 1. We will discuss about other immediate cardiovascular response to aerobic exercise in the next video presentation. Thank you.